Alright, we're doing like, we have to find the slope, and then we have to like find the distance between the 2 points.
Okay, good. That's stuff you can verbalize. So why
Yeah.
don't you give me one of those problems?
Alright, so A is 1 minus 1. No, these are like the points on the plane.
In other words, we have a point
So we have
that's
to
1
find the slope.
minus 1.
Yeah.
Okay.
B is 0, 2.
Okay.
C is 4, 4. And D is 5, 1.
Okay.
And now like I gotta find the slope.
Between A and B or B and C?
A and B.
A and B. So
Yeah.
slope between A and B. How am I going to get it?
1 over.
Remember one very important thing about slope. That is what you should always remember.
Alright.
Because that tells you what to do first.
Yeah.
In other words, if it's rise over run, well, this is the rise.
Yeah.
This is the run. Which one is the change in y's and which one is the change in x's?
The change in Y is the first, the 1 and 0.
Rise, exactly. So
Yeah.
I can replace that by the change in y. I can replace this by the change in x. Well,
Yeah.
what does the change in y mean? It means y sub 2 minus y sub 1. The change in x means x sub 2 minus x sub 1. So all we have to do is fill in. What is y sub 2 minus y sub 1? Probably the way you should label these is that's y sub 1, that's x sub 1, this is y sub 2, and this is x sub 2.
Yeah. So 2 minus 1.
2 minus a what? A minus 1.
Yeah.
You can't just drop those negative signs.
Yeah.
In other words, when you have minus a minus, you have to make sure you put both minuses in there because it turns it plus. If I put just 2 minus 1, I'm only going to get 1. But if I put 2 minus a minus 1, I get 3. Okay, what's the x sub 2 minus x sub 1?
Negative 1.
Correct. So we have 3 over negative 1. What is our slope?
3 over negative 1.
Negative 3.
Oh, negative 3.
In other words, that can be reduced.
Yeah.
That, remember, when you always, that negative sign doesn't matter whether it's in the numerator, the denominator, or out front. And we don't need the 1. So this turns into that. Okay, so now that we have slope, which format should we, what did they want? They wanted the equation of the line between A and B, right?
Yeah.
Okay, so we've got 2 choices. What are your 2 formats that you know about for equations of a line?
What's
the most common one?
I forget what it's called.
Slope-intercept.
Slope-intercept. Y equals mx plus b.
That's the most common one.
Yeah.
Okay. We can actually use that one for this.
Okay.
Well, we know m, right?
Yeah.
So we know this much. Now how can we solve for b? Because to come up with an answer, we got to come up with what b is.
Yeah. Yeah. Oh, we have to put in the equation?
Be more specific. What do you mean?
I don't know.
We have to take one of these points
Yeah.
and plug it in for the x and y value here.
Oh, yeah.
And it doesn't matter which point. Both of those points are on that line.
Yeah.
Okay? So pick one of these points and let's plug it in for y and x.
0 and 2.
That's the easier one for sure. Because the moment I plug in 0 for x, it takes care of that term.
Yeah.
So what's b equal to?
-1.
Now hold on. Look at my picture. What's b equal to? When I said it took care of that term, it made it 0.
Oh, so 2?
Yeah. So b is 2. Okay, so now I can plug in for the b, and there's the equation of the line from A to B. Now, I presume since they gave you 4 points here, they want the equation of the line from B to C also.
Yeah.
Okay, what's its slope?
4 and 2, 4 over 2, or -4 over -2.
Which one goes in the numerator?
X.
No. Remember, rise over run is the change in the rise, which is the change in y.
Okay.
So what goes in the numerator?
Y.
The change in the y, which in this case, what's the change in the y between B and C?
2.
What's the change in the x?
4. Alright,
So our slope is 1/2, positive.
Yeah.
Because all we have to do is make sure we go in the right direction. In other words, if we're going to do 4 minus 2, we got to go 4 minus 0. So 1/2 is correct. So let's use the same general formula. So we can say y equals 1/2 x plus b.
Yeah.
Solve for this. Tell me what to write next.
2 equals 1/2 times 0 plus b.
B is equal to?
Is it 2?
Uh-huh. I'm leaving room here. That's why I'm erasing stuff, because we need to go down. Okay, so that is the equation from B to C.
Yeah.
So now let's do C to D. That's the last part?
Yeah.
Okay, what's C to D? Slope.
-3 over -3 over 1.
Uh-huh, which is -3.
Yeah.
Okay, so now we got y equal -3x plus 2.
Yeah.
Give me a point.
4 and 4. So 4 equals -3 times 4 plus 2.
Plus b. Excuse
Plus
me,
b.
I didn't mean to write 2 there. We had so many 2's that I was thinking in my head 2, but I didn't mean to write it. So what's b equal to?
So -12. Wait. -8.
Okay, let's look at this further. What's -3 times 4?
-12.
Now how do we
wait.
solve for b?
divide by 4?
No, we add 12. In other words, when we're
Oh,
trying to solve for b, we're trying to isolate b.
yeah.
So forget everything else. Let's just try to get b on one side all by itself. Well,
Yeah.
all I have to do is get rid of that negative 12, and I'll have b on one side all by itself.
Yeah.
So if I add 12 to both sides, I get 16.
Yeah.
So now I can plug in 16 for b. And there's the equation from C to D. Let's practice a little algebra.
All right.
I'm just going to make up algebra problems.
Okay.
I want you to solve them. Just give me the next line.
Alright, so
Okay, tell me what you're going to do to each side to get the next line.
well, you have to try to get 3x by itself,
You're
right?
trying to get x by itself.
X by itself. So
But it's a process. In other words,
Yeah.
we get rid of each of these other numbers one at a time.
yeah.
How do we get rid of the 4?
Times the equation by 4.
Yeah, you always do the opposite of what the 4 is doing.
Yeah.
Right now the 4 is the divisor. So we want to multiply both sides by 4. And that gets rid of that denominator.
Yeah.
And that's key. Getting rid of denominators is really a good first step.
Yeah.
What's the next step?
U minus 2.
Okay, so I got 3x equal 18.
Then you divide by 3.
Right, the final step is because 3 is a multiplier, we want to divide by it.
Yeah.
So x equals 6. Okay?
Yeah.
Let me modify the problem very slightly. Let's see, it was 5. We'll leave that part. But this time, I'm not going to have the fraction bar go all the way over. In other words, it's 3x over 4 plus 2 equals 5. So
Okay.
what's my first step here?
You should still get rid of the 4, right?
Well, you actually have a choice as to what your first step is here. We're still going to want to get rid of the 4, but we have a choice as we can move the 2 on the other side first or second.
Mm-hmm.
Personally, I prefer to move the 2 out of the way immediately.
Alright.
Because if I multiply everything by 4, I got to multiply that 2 by 4 also.
Yeah.
Well, that just makes for bigger numbers. So
Yeah.
let's subtract 2.
Alright.
Notice now we still have our small numbers.
Yeah.
Now what?
Now we gotta times it by 4.
Okay. So now we got 3x equal 12. Divide by 3, x equal 4. Notice that had I done it the other way, and there's always a choice here, but if I want to multiply both sides of this equation by 4 immediately in order to get rid of that denominator, well, I do get rid of that, but then I got to multiply this 4 times the 2, so I end up with 3x plus 8 equals 20. Notice how much bigger my numbers are.
Yeah.
I got a 20, I got an 8, now I got to subtract 8 from both sides. Now we're back to the answer, but when I subtracted 2 first, my numbers were smaller.
Yeah.
So to me, that's the best way to go. Now, what if I had this problem?
Huh. Ooh. Could you find a common denominator between the x and 4 and x and...
Good start. What's the
Right.
common denominator going to be?
2?
A common denominator has to be divisible by both terms.
Alright, yeah.
2 is not divisible by either term. And when I say divisible, I mean evenly divisible.
Alright.
So 8 would be divisible by 4, but not by 3.
Oh, okay, yeah. So...
Way to find it.
12.
Right. But the way to find it is to take your biggest one, the 4, and start counting up by 4s. Well, you get 4, 8, 12. When you get to the 12, you realize both of these numbers divide evenly into the 12. So that's our common denominator.
I was thinking like 4 could go to 6 and like be divisible by 2, and then 3 could go to 6 and be divisible by 2.
Well, 3 goes into 6, but 4 doesn't.
Yeah.
6 is not evenly divisible by 4. It's 1.5, so it's an odd number. Okay, so we've got our common denominator. Now I have to figure out what to put here and what to put there.
Alright.
Remember the method. Here's the method.
Okay.
Take this number, divide it into the common denominator, and multiply it by the numerator. And that's what goes there.
Okay.
So what do you get when you do that? 3 goes into 12. How many times?
4.
What's 4 times x?
4x.
And the key thing is that that be the same thing as that.
Okay.
See how it is all it is multiplying top and bottom by 4.
Yeah.
So it is. And that's what you look for, is when you are finished, this fraction needs to be the same thing as that fraction. So what goes here?
Is 4x? Oh, wait.
Divide 4 into 12.
4, 8. 3 times.
3x.
Yeah.
And notice that 3x is the same as 1/4 x.
Yeah.
So that's the key whenever you're using common denominators, is just make sure you don't change the fractions. Okay, now how do I add two fractions with the same common denominator?
Just multiply across. Or just add. Wait.
Add numerators only.
Alright.
So that's 7x over 12.
Alright.
Equals 1/6. Now what? Trying to isolate x.
Alright, so
It's a good first step.
multiplying everything by 12.
Okay. Which is equal to 2.
Yeah. Right.
Now I have 7x equals 2. Final step.
Minus 7.
Not minus.
7.
Why is it not minus? It's because the 7 is not adding to the x.
Yeah.
It's multiplying the x. So you have to do the inverse of what it's doing. You have to divide everything by 7. So x is going to be 2/7. Okay. You bring up this thing again. Curious as to whether or not they have good algebra on here. Yeah, before we go to the algebra, I don't know if you've been using this, Julian, but I don't ever checkbox that column or this column.
All right.
The reason is that's not a particularly valuable skill. You don't need to know how to add two-digit numbers to one-digit number. You just don't.
Yeah.
The valuable skills are one digit by one digit. So, you give me the answer, I'll type it in. Let's go as fast as we can.
All right. Minus 15. Minus 18.
It's minus times minus.
Oh, 18. Three, positive 3. Minus 9. Ooh,
You put the whole number and it's a single digit number. What does it have to be? Notice what 1, 0, and 8 add to.
9.
Which means this thing has to be divisible by 9.
Yeah.
So that's probably a pretty good guess. Minus 9. Okay?
Minus 2. Minus 10.
Good.
Minus 2 plus 5. Minus 3. Wait, no, positive 3.
Good.
6 minus a minus 7. Negative 1.
Six minus a minus 7. When you have two minuses in a row like that,
Yeah.
they become a plus.
Okay.
Whether you're adding, subtracting, multiplying, or dividing, when you have two minuses in a row, it becomes a plus. So that is the same as 6 plus 7, 13. Remember what that other number was that added to 9?
Oh,
100 and what?
8. Minus 4. Minus 2. Minus 48. Minus 2, minus 4. Alright, is it 6?
Have more confidence in those answers.
Alright, minus 15.
Well, it left off the action that we were supposed to be doing here. Am I missing something? I don't see a plus sign. I don't see a multiplying sign. I don't see a subtraction sign. So I'll go with minus 15. Let's see if that's right. Yeah, okay. They meant add. They just didn't show the plus sign.
Alright, minus 40.
Yeah. See, this is where I'd like to see you get to a point where you don't have to think for that second.
Yeah.
You want to get so good at these that you can't make a mistake.
2. Minus 20.
See, I bet you can do 10 in a row. Do 10 in a row, starting from now.
Alright, minus 22.
This is not multiplying.
Oh.
There's no multiplication.
Oh, yeah, Yeah. So -9.
Two negatives in a row do what?
Turn positive, +9.
You have 11 plus 2.
Oh, 13. Alright.
This is addition. Well, actually, I see what they're doing. They're doing -9 minus 5, which is the same as -9 plus -5. So
Yeah.
when they don't put a sign there, it is subtraction. There's what they're doing, is subtraction. So what's -9 minus 5?
-14.
Okay? That's 2 in a row.
-4.
It's 3 in a row.
-4. Wait, no, -12.
That's 4 in a row.
Alright. +2.
5 in a row.
Oh, huh.
Okay, let me give you a little secret about nines. If you are multiplying 9 by any number, let's say I'm going to multiply 9 by 5. Well, my answer starts out with 1 less than the number I'm multiplying it by. And the next digit has to add to 9.
Yeah.
So what is 9 times 7 equal to? What's the first digit got to be?
6.
What's the next digit got to be?
3.
That's how you do nines.
Okay.
Okay? So, this is just the opposite. We're dividing, but we can still use that rule.
Yeah.
So what's this?
-7.
Uh-huh. Okay, that's 6 in a row.
-35.
That's 7 in a row. Subtraction.
-8.
8 in a row.
Ooh. Minus. -10.
Good. That's 9 in a row. Come on, get this one and we can go on to other stuff.
7.
Good. All right. When you can do 10 in a row, that's pretty good. And notice that they do, in other words, this plus sign here, what's the answer here?
0.
No.
Oh, wait, -14.
Good thing we weren't going for 11 in a row.
Yeah.
-14, right?
Yeah.
Take away the plus sign. What is it?
Negative. Wait. 0?
No, still -14.
Oh, yeah.
Because when I remove the plus sign, it's the same as this, -7 subtracting 7.
Yeah.
Well, this is the subtraction sign, so if you do what I recommend, which is to change that to an addition and change the sign on what was being subtracted, so I just put in a plus sign there and it didn't change anything.
Yeah.
Still -14. And notice that on this drill here, sometimes they put the plus sign, sometimes they don't.
Yeah.
All right, let's see. Flashcards with negative numbers. Let's see if they have any algebra flashcards. Don't see any. Subjects. Algebra. Perfect.
All
Y
right.
equals what?
Y equals
Okay, what are you going to do to each side?
divide by -3.
Okay, what's negative 36 divided by negative 3?
Negative positive 12.
Yep.
All right.
10y equals 20.
10y equals 20. Wait, so I'm confused.
Okay. About what?
I don't really know.
Okay. If 10y equals 20, how do we
Yeah.
isolate the y?
Oh, divided by 10.
Okay.
So wait, it's just 2?
Uh-huh.
Okay.
I'm glad I found this. This is useful. Okay.
Yeah. Alright, so -1 plus y equals 5. So plus 1, y equals 6. Alright, y equals 7.
If I have 7 minus y equals 14, and I
Yeah.
subtract 7 from both sides, I definitely lose the 7, but I'm left with a minus y equals 7.
Yeah.
So now,
So it's -7.
huh?
It's -7?
Yeah. But notice that there's really a way to do this. I mean, I could move the y to the right side, turning it positive,
Yeah.
and move the 14 to the left side, so I'd have 7 minus 14 equals minus 7. So I can get it in one step. I guess the other is one step also. I like to keep my coefficients of my variable positive. So if you present me with this problem, the first thing I'm going to do is move the y to the right. I'm not going to move the 7 to the right, because that leaves me with a negative coefficient. Not that that's wrong. I can still do the problem. I still have to then divide both sides by -1. It's just I like a positive coefficient.
Yeah.
I feel like it's less likely to make mistakes.
Yeah.
You leave yourself with positive coefficients. It's this one.
So no, so that's a plus y.
Yes.
So if I -1, then that turns into a negative y.
No.
Oh.
Minus
minus
1 gets rid of the 1 and leaves plus y behind.
All right. So y equals 3.
Uh-huh. Now do it the way I suggest.
So
Move the y to the right and the 4 to the left.
all right. So plus y. Y equals 10.
If you move the 4 to the left, you have to subtract it.
Oh yeah. 2.
Okay.
Y equals 3.
Okay.
Y equals negative. Negative 8.
Good.
Negative 2. Y equals -3.
Good. See why you need those arithmetic skills.
Yeah.
You just can't do algebra relying on a calculator. It's too hard.
Yeah. So y equals
Okay, there's two steps here, so don't try to do it all at once. What's the first step?
getting plus 12
Okay,
each side
so now you have minus 4y equals what?
equals 20.
Okay, now what's y equal to?
Negative 5.
Good.
Alright, minus 1.
Good.
Alright. Y equals 9.
Good.
Y equals negative 8. Y equals 8. Oh, so
Do you have paper in front of you?
yeah.
Go ahead and scribble on it, because these need two steps.
Alright. Alright, so you minus 8.
It's minusing right now. So you got a plus 8 to get rid of it.
Yeah, that's what I meant.
Okay.
So 46?
44.
44.
Negative 44.
Negative 44. So minus 11y equals negative 44.
Correct.
So minus 4.
Got minus 11y
Yeah.
equals minus 44. What's the next step?
Adding 11.
Not adding.
Oh.
It looks, I can understand why you said that, because you're looking at that, and that looks like 11 might be being subtracted.
Yeah.
But the key is to figure out what the 11 is doing. If it was really being subtracted, it would look like that.
Yeah.
Since it's next to the variable, that's multiplication. It's just minus 11 times y.
Yeah.
So what do I have to do?
Divide.
By?
Negative 11.
What's that answer?
4. Y equals 5.
It's got to be relatively exciting, because I think for the first time you're able to do these.
Yeah.
Am I right or wrong?
Yeah, you're pretty right.
Yeah. And it's going to be hard to go. Yeah, we should have done this last year. If I'd have known about this A+ math, we would have.
Yeah.
But once you master the single-digit arithmetic and you master how to solve simple equations like this, you are going to be so much better off to handle geometry and then Algebra 2 next year.
Yeah.
Absolute requirement that you be able to do these. Otherwise, you can see clearly that you wouldn't have stood a chance. Right?
Yeah.
Okay, what's this?
Y equals negative 2.
Good.
Alright. So y equals 8.
Good.
Oh. Alright. Y equals 4 or negative 4.
Well, which is it?
Negative 4.
Yeah. In other words, there's two ways to do it. I can move the y over, but that means I got to move the 9 to the left. So when I move the y to the right, I get that, but when I move the 9 to the left, I get that. So y is equal to negative 4. Now, the other way to do it is the way you wanted to do that very first one, which is to leave the y here and let's move the 5 to the other side. That's not a bad way to do it.
Yeah.
Gives us a positive x coefficient over here. And whenever you have minus a variable equals a number, well, you know that the answer is just the opposite sign.
Yeah.
In other words, you have to divide both sides by minus 1. So you get minus 4 as the answer. Whichever way you like to do that is fine. Don't pretend that that technique I said was the correct way to do it. It's just the way I like to do it. I prefer to keep my coefficients positive.
Yeah.
But it's not that big a deal.
Alright,
In this case, I probably would not move that minus 5y to the right side.
Yeah.
Just because it's got a coefficient in front of it. I'm not going to mess with that. I'm going to move the minus 4 to the right side, giving me what? Minus 5y equals...
Negative 18. Wait, no, negative 10.
Okay, and then y would equal what? If minus 5y equals negative 10, what's y equal to?
2.
Correct.
Alright, 9.
Okay. This one?
Hold on, can I go let my dog outside real quick?
Sure.
He's barking a lot. Alright, I'm back.
Okay. Let's try some slightly tougher ones that I'm going to make up.
Alright.
No, not that. Excuse me.
Alright. So,
yeah, tell me the steps. In these algebra equations that I'm going to write, tell me first step, second step.
Alright. So you multiply everything by 4.
Giving you what?
Y equals
Huh?
3y.
Okay.
3y equals 24.
Okay. Next step?
Divide by 3.
Okay. So y equals?
Ooh. 8?
Yeah. Now, that's the answer.
Alright.
To verify to yourself that that's the answer, count by 8s 3 times.
Yeah.
8, 16, 24.
Alright.
Okay? In other words, after you've done this division, always check to make sure that 8 times 3 equals 24.
Yeah.
That's the definition of division, is resultant multiplication has to be true. Now, you did this in 2 steps.
Yeah.
Dividing by 4, multiplying by 3. If I want, I can multiply both sides by the reciprocal of that fraction.
Yeah.
1 step. Notice what happens when I do that. Those lose and those lose. I'm left with a y. y equal 24/3 equals 8. Slightly quicker.
Yeah.
Instead of 2 steps, it's 1.
All right.
Do the new technique, yeah.
So wait, what did you do?
Multiplied by the reciprocal.
So 6/5?
Uh-huh. In other words, you have to do, notice that that's the same exact thing as what you did. It's just you did it in 2 steps. You multiplied by 6, and then you divided by 5.
Yeah.
That's what we're doing, is multiplying by 6 and dividing by 5. It's just that we're going to do it in 1 step.
Yeah.
Okay, so those disappear.
Yeah.
We end up with, now, how would you do that?
Ooh, we need a common denominator?
No. Multiplying is much easier than adding.
You just multiply across?
Yep. I could do that, which gives me 6/60.
Yeah.
But there's an easier way to do it. In other words, I don't want to deal with numbers as big as 60.
Yeah.
So let's do something with this 6 and 12. What can I do with 6/12?
Make it 2 over, 1 over 2?
1 over 2.
Yeah.
In other words, I'm going to divide the top by 6, leaving 1, and I'm going to divide the bottom by 6, leaving 2.
Yeah.
Now, I have 1/10, which is what 6/60ths was 1/10. But never deal with big numbers if you can help it. And always reduce before multiplying.
Yeah.
Because sometimes it'll make a huge difference. If I've got something like 8 times 35 divided by 7 times 2, gosh, if I multiply, I've got like 280 in the numerator and 14 in the denominator, who knows? But I can divide top and bottom by 7, giving me 5 there. I can divide top and bottom by 2, giving me that, and now my answer is 20.
Yeah.
Much easier to reduce before multiplying or adding. Okay, let me think of tricky little things that trip a lot of people up. Combine those two. How do you subtract a whole number from a fraction?
I have no idea.
Find a common denominator. In other words, addition and subtraction of fractions is always about finding a common denominator. That's what makes it harder than multiplication or division.
Yeah.
I mean, if I want to do multiplication, that's a piece of cake.
Yeah.
That's 6/12. Just multiply across. But if I wanted to add those two, all of a sudden it becomes much harder.
Yeah.
Subtraction, same way. Division is no problem. If I want to divide 2/3 by 3/4, that's easy because that's really a multiplication problem.
Yeah.
That's the same as multiplying by the reciprocal 4/3.
Yeah.
And then that's easy. That's 8/9. So multiplying and dividing has always been easy. It's addition and subtraction that's tough. So what's the common denominator going to be?
1.
No, remember that whatever it is, both denominators have to divide evenly into it.
Yeah.
Got to be x. X divides evenly into x one time. and 1 divides evenly into x times.
Okay.
Okay? So that's the same numerator there, right? That doesn't change. But what does this become over here? Do the same process. Divide 1 into x, take your result, and multiply it by this one.
So it becomes 1.
Well, now check and see, is this the same as that?
1x, yeah.
No, it isn't. This is the number 1. This is 1 over x.
Oh, yeah.
So if we do it, divide 1 into x goes x times.
Okay.
X times this one is x.
Yeah.
And now notice that x over x is 1.
Yeah.
That's the same as this.
Okay.
The only beauty is that it's got a denominator that is common with this other fraction.
Yeah.
So when you're done finding common denominators, always make sure that you have the same thing you started with.
Yeah.
This is 1. Okay, now how do I subtract those two?
Wait. So 1 over x minus
X over x. You have a common denominator.
X.
Right? And then operate on the numerators.
1 minus x equals...
That's it. That's the answer. That's what 1 over x minus 1 is equal to.
Alright.
And all we were doing was a little bit of a... For some reason, people, when they see this problem here, they don't think of it as a common denominator problem.
Yeah.
In other words, if I said this to you, well, clearly you're going to say, I got to find a common denominator.
Yeah.
So let's do this one.
Alright.
What's the common denominator?
12.
What goes here?
Here.
Remember how to get it? Divide 3 into 12. What do you get?
Right. 4.
And multiply it by the numerator, 2.
8. Alright, so...
Notice that 8/12 is the same as 2/3.
Yeah.
If I wanted to take this fraction and reduce it, I would divide top and bottom by 4, and it would reduce down to 2/3.
Yeah.
Okay, what goes over here?
9.
And what's the answer? What's 8/12 minus 9/12?
1, negative 1/12?
Yep. Good. Alright, let me think here of the kind of equations. You've only had linear equations, is that correct?
Yeah.
By linear, I mean you haven't had anything that looks like this?
With the square root?
Uh-huh.
I don't think so.
Okay. And you haven't had anything that looks like this?
With the square... I think we've just been doing like...
Linear. Linear means you have the variable is to the 1 power.
Yeah.
Okay. So let me make up complicated linear algebra equations.
Alright.
This is probably as complicated as you'll see as long as you're talking linear equations.
Alright.
There's various ways to do this. There's a very, very simple first step that changes the whole problem.
Okay. And so is that getting the 1/5 with the 1/35th?
No, actually not. What it is recognizing that I can rid the equation of all three denominators in one step.
Yeah.
What do I have to do?
Alright. You have to find a common denominator.
Well, we're looking at it, 35.
Yeah.
But this is not the same as adding two fractions. In other words, I am not going to find a common denominator and do that right there.
Alright.
That's one way to do it, but it's the hard way.
Yeah.
Let's do it the easy way, recognizing that if I multiply everything by 35, I will get rid of all denominators in one step.
Yeah.
What is that equal to?
Okay. So 35 times a minus 5.
No, let's not do it that way. Let's do it the way I just was talking about.
Alright.
Seven goes into 35 how many times?
5.
Okay. So I'm really multiplying 5 times minus 5x.
Yeah, alright.
So what does that leave?
Minus 25x?
Okay. That's this multiplication.
Yeah.
Now do the same thing. We have to distribute that 35 to that term.
Okay.
What's that going to be?
I don't know.
What's 35 divided by 5?
35 dollars.
In other words, if 35 divided by 7 was 5,
Yeah.
35 divided by 5's got to be 7.
Yeah. Okay.
That takes care of the whole left side of the equation. What's the right side of the equation become?
1.
Now, notice how much easier this equation has gotten in one step.
Yeah.
Far easier than going through and finding a common denominator and adding these two fractions and then proceeding.
Yeah.
So whenever you see an equation where you can eliminate all the denominators in one step, look to do it, especially if it's easy. In other words, I made up easy numbers here. I made up 7, 5, and 35, their common denominator. Okay, what's the next step here? Let's finish this problem.
Minus 7.
Okay, so what do I got now? Minus 25x equals?
Negative 1.
Got 1 minus 7.
Minus 6.
Okay. Now what?
Do you divide by 25?
By negative 25.
Negative 25.
Remember, we're always trying to isolate the x. So x is equal to minus 6 divided by minus 25, which is equal to a positive. 3 goes into that twice.
Yeah.
Whoops, hold on a second. Why did I think that reduced? It doesn't. That's 6/25.
Okay.
Okay. I was thinking that reduces for sure, but it doesn't. But it does become positive. In other words, you don't want to ever give an answer like that, because that's clearly not simplified. In other words, if you have a minus divided by a minus, at the very minimum, change it to a plus answer. All right. That was very good tonight.
Yeah.
Very good. Yeah, work on, do you have this A plus math?
Yeah, I saved it to my favorites.
Okay, good, good. You might check out the algebra, although these aren't very hard, and you were pretty good at these. but
Yeah.
you want to get perfect. Both the
Okay.
algebra and the math flashcards with the positive and negative numbers, you want to be able to always do 10 in a row. If you can't
Yeah.
do 10 in a row, your math skills need sharpening, and you
Okay.
should practice. Practice until you can do 10 in a row. That's almost
Okay.
what I would say would be, I would say when you go in to practice, the moment you can do 10 in a row, you're done.
Okay.
Okay? But make sure you can do 10 in a row.
All right.
All right. I will talk to you next time, Julian.
Okay. Thank you.
Bye-bye.